How Mars lost its shield, and everything after that. Mars was not always exposed. For a long time, it was protected by something invisible, powerful, and essential. When that protection vanished, everything else followed. The magnetic field that once enveloped Mars was not merely a planetary feature, but a life support system, a shield against cosmic forces that would otherwise strip away the very foundations of habitability. Its presence made Mars a candidate for life. Its absence guaranteed decline. This is a story of how an invisible shield determined the fate of an entire world. To understand why Mars matters today, we need to focus on what cannot be seen. A planet's surface tells only part of the story. What truly determines survival lies deep within. Mars once had a magnetic shield strong enough to defend its atmosphere and regulate its climate. That shield made life possible. Its loss made decline inevitable. The magnetic field was generated deep in the planet's core, where churning molten metal created electrical currents that produced a protective magnetic bubble extending far into space. This magnetosphere deflected the solar wind, a stream of charged particles constantly flowing from the sun, preventing it from directly interacting with Mars's atmosphere. Without this shield, the planet was defenseless against the relentless erosion of its atmospheric envelope. Early in its history, Mars possessed a molten, active core. This churning interior generated a global magnetic field, similar in purpose to Earth's. It deflected solar radiation and held the atmosphere in place. With that protection, water could remain liquid, climate could stabilize, time could work in Mars's favor. Evidence for this ancient magnetic field comes from magnetized rocks in Mars's crust, particularly in the ancient southern highlands. These rocks preserve a record of the field's direction and strength at the time they cooled and solidified, providing a frozen snapshot of Mars's early magnetic environment. The field was substantial. Estimates suggest it may have been comparable to Earth's current field in strength, creating a protective cocoon around the young planet. But Mars was small, and small planets cool quickly. As internal heat escaped, the core slowed. The magnetic field weakened, and when it weakened enough, it failed entirely. Mars lost its shield without drama, without warning, and without recovery. The planet's size, roughly half Earth's diameter and 1/10 its mass, meant it had less internal heat to begin with, and a higher surface-to-volume ratio that accelerated cooling. The molten outer core that generated the magnetic field gradually solidified as heat radiated away into space. Once a critical threshold was crossed, convection in the core ceased, the dynamo shut down, and the global magnetic field collapsed. The timing of this collapse is debated, but evidence suggests it occurred relatively early in Mars's history, perhaps within the first few 100 million years. The shield did not fade gradually, but likely failed relatively abruptly on geological timescales, leaving Mars suddenly vulnerable. Once exposed, the planet changed immediately. Solar wind began stripping the atmosphere molecule by molecule, not violently, but continuously. The loss was invisible day to day, but devastating over millions of years. Mars could no longer protect what it had built. Without the magnetic shield, solar wind particles penetrated directly to the upper atmosphere. There, they collided with atmospheric molecules, imparting energy that allowed some molecules to escape Mars's gravitational hold entirely. Others were ionized and swept away by electromagnetic forces in the solar wind itself. The process was subtle but inexorable, operating continuously year after year, century after century, slowly but steadily thinning the atmosphere that once might have resembled Earth's. This moment marked a turning point. The planet did not collapse overnight, but its future was sealed. Without a shield, every system became temporary. Water stability, climate balance, atmospheric pressure. Mars entered a slow, irreversible unraveling. The loss of the magnetic field initiated a cascade of consequences, each reinforcing the others. Atmospheric loss reduced greenhouse warming, which lowered temperatures, which reduced the capacity of the atmosphere to hold water vapor, which accelerated further atmospheric loss. Each element of the system that might have sustained habitability was compromised, and the compromises fed back on each other in destructive loops. The loss of Mars's magnetic field was not just one event among many. It was the event that made all others possible, and everything that followed traces back to that invisible failure. This was the linchpin moment in Martian history, the transition that determined all subsequent evolution. Had the magnetic field persisted, Mars might have retained a thick atmosphere, stable surface water, and moderate climate for billions of years. Without it, the trajectory toward barrenness became inevitable. Once Mars lost its magnetic shield, the planet became vulnerable in ways that were not immediately obvious. The surface still looked solid. The landscape still held memory. But above it, the atmosphere was slowly bleeding away. The changes were not instantaneously catastrophic, but gradually cumulative. For perhaps millions of years after the magnetic field collapsed, Mars might have appeared relatively unchanged. The atmosphere was thinner than before, but still substantial. Water still flowed in some regions, but the trajectory was set and the destination was fixed. Solar wind struck the planet directly, carrying charged particles that stripped gases into space. Lighter elements escaped first. Hydrogen from water vapor vanished. Oxygen followed. Over time, the atmospheric pressure dropped below the threshold needed to support liquid water. The preferential loss of light elements altered atmospheric composition as well as total pressure. Hydrogen escaped most readily, breaking apart water molecules and stripping away one of the key building blocks for maintaining a hydrological cycle. Oxygen, though heavier, was also gradually lost through various escape mechanisms. Heavier gases like carbon dioxide and nitrogen were lost more slowly, but still inexorably declined over geological time. The atmosphere didn't just thin. It became chemically different as selective loss processes favored certain elements over others. As pressure fell, water became unstable. Lakes evaporated. Rivers ceased to flow. Ice retreated beneath the surface or locked itself into the poles. Mars did not lose water all at once. It lost the ability to keep it. The relationship between atmospheric pressure and water's phase behavior is critical. Below a certain pressure threshold, approximately 6 millibars, Mars's current average surface pressure, liquid water cannot exist stably regardless of temperature. Water transitions directly from ice to vapor without passing through a liquid phase. As Mars's atmosphere thinned past this threshold, any remaining surface water evaporated, and the vapor either escaped to space or froze onto the polar caps or subsurface ice deposits. The planet transitioned from a world where water could flow and pool to one where it could only exist as ephemeral frost or buried ice. The climate responded accordingly. Without a thick atmosphere to trap heat, temperature swings intensified. Days grew hotter. Nights grew colder. Seasonal balance collapsed. Mars entered a state where moderation was impossible. A thick atmosphere acts as a thermal blanket, absorbing heat during the day and releasing it slowly at night, moderating temperature extremes. As Mars's atmosphere thinned, this buffering capacity diminished. Surface temperatures began to swing more wildly between day and night, between summer and winter, between equator and poles. The planet lost the ability to maintain equilibrium. Extreme environments are inhospitable not just because they are harsh, but because they are unpredictable, offering no stable conditions to which organisms could adapt. This exposure also affected chemistry. Radiation penetrated the surface, breaking down organic molecules. Any potential biosphere faced relentless assault. Survival required retreat underground, adaptation beyond recognition, or extinction. Without atmospheric shielding, harmful ultraviolet radiation reached the surface at intensities far exceeding Earth's. UV light breaks chemical bonds in organic molecules, degrading amino acids, nucleotides, and other biological building blocks. Any surface-dwelling organisms would have been sterilized by this radiation. Even subsurface life would face challenges as cosmic rays and energetic particles penetrated meters into the regolith. The loss of the magnetic field didn't just make Mars cold and dry, it made the surface actively hostile to organic chemistry. What makes this loss so significant is its permanence. Magnetic fields do not regenerate easily. Once the core cooled past a certain point, the shield could not return. Mars crossed an invisible boundary and never came back. Unlike atmospheric loss, which could theoretically be reversed through volcanic outgassing or cometary impacts, the loss of the magnetic field represented a one-way transition. Restarting a planetary dynamo would require reheating the core sufficiently to restore convection, a process that would demand energy inputs far beyond anything Mars could access naturally. The magnetic field's collapse was effectively permanent, making all subsequent losses permanent as well. Every subsequent change traces to this moment. The storms, the cooling, the dryness. Mars did not simply lose its shield. It lost its future. The dust storms that scoured the surface, the plummeting temperatures that froze any remaining water, the progressive desiccation that transformed Mars into a desert. All of these followed from the fundamental vulnerability created by magnetic field loss. The shield was a keystone, and when it fell, the entire structure of Martian habitability collapsed, and that loss reshaped the planet in ways that are still unfolding today. Mars continues to lose atmosphere to space even now, billions of years after the magnetic field collapsed. Spacecraft observations have measured ongoing escape rates, confirming that the process is active. The planet will continue thinning indefinitely, approaching but never quite reaching absolute vacuum. The consequences of that ancient lost compound across geological time. The conflict created by the loss of Mars's shield lies in how deceptively survivable the planet appeared afterward. For a long time, Mars still looked familiar. Valleys remained. Ice persisted. The surface held echoes of stability that masked deeper collapse. This created a lag between cause and consequence, between the failure of the shield and the full manifestation of its effects. Mars did not instantly transform into the barren world we see today, but underwent a prolonged transition lasting perhaps hundreds of millions of years. This illusion delayed understanding. Mars seemed wounded, not doomed. Scientists once believed the atmosphere might stabilize at a thinner state. That water could linger underground indefinitely. That life, if present, might adapt and endure. The planet appeared weakened, but not finished. Early models of Mars's evolution were more optimistic, suggesting that even without a magnetic field, atmospheric loss might eventually reach an equilibrium where escape rates matched outgassing from volcanism. Water might persist in subsurface aquifers, protected from surface conditions. Life might retreat underground and continue in isolated refuges. These hopes were not unreasonable given the evidence available, but they underestimated the totality of the collapse initiated by magnetic field loss. In reality, the shield's loss had already decided everything. Without protection, every remaining system was on borrowed time. The atmosphere could only thin further. Water could only retreat. Climate could only destabilize. Mars entered a one-way process. The trajectory was fixed even if the final state was not yet reached. Every day brought Mars incrementally closer to its current condition, and no natural process could reverse the trend. The decline was not a possibility but a certainty, written into the planet's physics once the magnetic shield failed. This creates the central tension of the story. Collapse does not always look like collapse. It can resemble survival long enough to confuse observation. Mars demonstrates how a planet can appear functional while already past recovery. This has profound implications for how we assess planetary habitability elsewhere. Surface conditions are important, but the presence or absence of a magnetic field may be the ultimate determinant of long-term habitability. A planet might look hospitable at a given moment, while already doomed by processes operating too slowly to be immediately obvious. The conflict deepens when compared to Earth. Earth's magnetic field is taken for granted, invisible, constant, rarely discussed. Mars reveals what happens when that protection disappears. Not instantly, but inevitably. Earth's magnetic field, generated by convection in its liquid outer core, have persisted for billions of years and shows no sign of imminent collapse. We live under its protection without conscious awareness, shielded from the full force of the solar wind that would otherwise erode our atmosphere as it eroded Mars's. The comparison makes clear that Earth's habitability depends fundamentally on this invisible shield continuing to function. Mars did not fail because it lacked water or warmth. It failed because it lost defense. And once defense was gone, no surface feature could compensate. This reframes the entire narrative of Mars's decline. The focus shifts from superficial factors like temperature or water availability to the fundamental protective system that enabled those conditions in the first place. Without the shield, no amount of water, no thickness of atmosphere, no warmth from the sun could sustain habitability because all would eventually be stripped away. This reframes planetary danger entirely. The greatest threats are often unseen. When they weaken, everything else becomes temporary. Mars did not announce its end. It simply continued until it could no longer continue at all. The lesson extends beyond Mars. Planetary stability depends on systems operating far beneath the surface, invisible to casual observation, but fundamental to survival. The failure of these deep systems dooms everything above them, regardless of how stable surface conditions might appear. And by the time the consequences were undeniable, the outcome had already been sealed. By the time Mars's atmosphere was obviously thin, its surface obviously dry, and its climate obviously hostile, billions of years had passed since the magnetic field collapsed. The causal chain stretched back to an event long concluded, its effects playing out across geological time. Mars was not declining. It had declined, and what we observe today is a final state of a transformation initiated in the distant past. The climax of Mars's lost shield is a realization that nothing on the surface could ever replace what was lost beneath it. Once the magnetic field failed, no mountain, ocean, or atmosphere could save the planet. The failure was too fundamental, too deeply rooted in the planet's interior structure and thermal evolution. Surface processes could not compensate for the loss of a core-generated global magnetic field. The decline was irreversible not because no one tried to stop it. No one could, but because the physics allowed no alternative. Mars's future collapsed not from a single disaster, but from the absence of protection. Exposure turned time into an enemy. Every solar particle carried away possibility. Every passing era reduced what could survive. Without the shield, time worked against Mars rather than for it. Each moment brought more atmospheric loss, more water depletion, more climate destabilization. Longevity became liability. The longer Mars existed without protection, the more thoroughly it was stripped of everything that made it potentially habitable. The resolution of this story is stark. Some losses cannot be engineered away. Some systems, once gone, and everything that depends on them. Mars teaches that survival begins deep below the surface, long before life appears above it. The lesson is humbling. Habitability depends on foundational systems that cannot be easily repaired or replaced. A planet's magnetic field, generated by processes operating thousands of kilometers below the surface, determines outcomes for everything living on or near the surface. No amount of surface engineering could substitute for the deep planetary processes that generate protective magnetic fields. Today, Mars stands exposed, unguarded, and permanent in its outcome. A planet that shows what happens when invisible foundations fail, not through drama, but through inevitability. Mars will never recover its magnetic field through any natural process. It will never restore its thick atmosphere, its flowing water, or its moderate climate. The state we observe today is final. The endpoint of transformation initiated billions of years ago when an invisible shield failed and could not be restored. Mars lost its shield, and with it, the chance to remain a living world. What remains is a record of what protection truly means. Mars is not a cautionary tale in the sense of warning against specific actions. Nothing could prevent its fate, given its size and structure. But it is instructive in revealing the absolute necessity of certain planetary systems for maintaining habitability. The magnetic field was not a luxury but a requirement, not an enhancement but a prerequisite. Without it, Mars's transformation from potentially habitable to definitively barren was not just possible but inevitable. Subscribe to join the journey. How